In my last video, I described how to write a wave file in C. And what we wrote is just a basic middle C note that was played continuously. And so here I'll play it right now. So we just made a 10-second clip that plays middle C, and you can find that full source code here, as well as the sound itself. And then what we're gonna work towards today, we'll use a lot of code from the first one in terms of writing the wave file, but this time we're actually gonna be playing chords and kind of constructing more of a proper song. And so if you've never seen the 4 chords by Axis of Awesome, I'd recommend having a look at that. But essentially if I play this, it's playing 4 chords and it's kind of looping that through. And so what we're going to do is we're going to talk through how this actually works. We're going to do it in the code editor so you can see correct syntax highlighting. So this we brought over from before. So this is just our struct to store the actual wave file itself. Nothing has changed there. That's exactly as we did in the last video. And then this here is new. So I only needed certain notes, and there's obviously ways that you could do this differently, especially if you're doing more notes. But if you take a look, I put this link here. You can find the frequencies for all of the different notes that you might exist. Those are all the notes that we needed to play our 4 chords that we were looking to play. Then we kind of construct some variables for how our song's actually going to be played. We still got our sample rate from before, the number of measures that we want to play. And so playing each chord for a measure, but then we want to repeat it 4 times. And so that's how we get this 4 times 4. Beats per measure, that's the number of times we're playing it in, so that's 4. And then this milliseconds per beat is how long each beat actually lasts. And the reason that we need these is to compute how large our buffer size is, so that when we actually fill this buffer, it is the length of song that we actually want. What we're kind of constructing here is take the sample rate times milliseconds per beat, and this tells us the number of samples that exist per beat, and then we multiply that by the beats per measure, and finally the number of measures to play. And then we get our buffer size. We'll jump to the main function. In here again, this is what we saw before, so this is just preparing our wave struct. Where things start to differ is below here. We initialize what measure that we're on, starting, and then we go through up to the number of measures that we want to play. And how I ended up doing this is I put them all in a row and actually incremented along the way. It's not great, but I'm using this as an experiment to learn, so it's not so bad. And so here, the play function essentially plays a single note at a time. And so what I'm doing here is kind of essentially playing the bass line. And so this is a D2 and a D3 that will be played. And then these are actually the full chord. So D is for D major. And then when we move on to the next measure, now we're on an A. And so we play the A in the bass line and then A major. And this is the first inversion. If you don't know about inversions, you can look that up. And then same here. Now we move to the B minor first, and then we play into G. And then this is just going to loop however many times we've asked it to play. And so let's take a look first at the play function. Play takes in a frequency, the duration, measure, and the beat. And so let's take a step back here. Here you'll see both of these pass in 0 for the beat. So again, here is that signature while we're looking at it. And so the first parameter of play is the frequency. So this constant D2 is the frequency of a D2 note. And then the second one is the duration. And I maybe didn't name this well, but that duration is essentially the number of beats that should last. And then the measure specifies what measure this is actually on. And then finally, the final one is what beat within that measure that we're actually on. And you'll see why those come into play inside this play function. We're essentially looking for the start and end index of where we are within the buffer. And so we have this semi-global variable of the buffer. And when we play, we're telling it what measure and what beat to be playing on. And so then we can construct the start and the end index for where we want to play this actual note. And so again, here we identify, okay, beats per measure times measure plus whatever beat that we're on. 1, 2, 3, correct. Yeah, that makes sense. And then the number of samples we beat tells us what offset we need to be to get to the start of that beat in terms of the index of the buffer. So kind of it's a little bit confusing because we're operating between like real life time versus the index within our buffer. And so then this should look very similar to what we did in the previous video, where this frequency is now just what's passed in. So before it was hard-coded, but now we can pass in a configurable one. And then we're just constructing that same cosine wave of our sound. And then this is kind of just like our base volume multiplier. Like that probably could have been put in a variable elsewhere to be less confusing. But then here's our amplitude multiplier, and that's this envelope. So what this amplitude multiplier is essentially doing in these different stages, it's creating an audio envelope. And so here you can see the attack slowly builds in the amplitude until you hit the maximum here. And then there's a bit of a decay. And so if you imagine playing a piano, when you first hit the note, it's quiet, but then it pretty quickly gets to full volume. And then it gets a little bit quieter. And then it possibly gets sustained for a period of time until it's actually released, and then it tapers off. That's what this section is mimicking. And that's why we multiply it there. So that's to play a single note. And then if we head back, we can see the chords here. These are essentially just helper functions so that we don't need to individually play every single note. So we take a look at the D major. All it's doing is specifying the 3 different notes of that chord to play. And you'll just find the same thing across the different ones. But once you've done this, you kind of get this neat visual way of seeing your audio in code. And so visually, this is describing exactly what you might be playing on a keyboard, for example. So at the end here, we have the same file writing code that we had from before, and that's just to actually get us the wave file. Let's just compile this quickly. And so if we run it, it'll give us an a.out. And then if I run that, it'll generate a test wave file. And then you'll hear the same thing that we had from before. I'll put a link to this page in the description of this video so that you can find the full source code here, so that you don't need to kind of pull it off of the video. And then you can experiment with it and see what works for you. I'm still debating where to take this project from here. One option might be creating a sound that's less mechanical. And so this one clearly just sounds like a sine wave, and I might be interested in exploring how to make it sound like a grand piano, for example, or just kind of mess around with that. Or a completely kind of different alternative might be actually bringing in some kind of like computer generated vocals on top of this as well. We'll see what comes out. If you have an interest in either of those, feel free to put that in the comments, or if you have any other ideas, feel free to put those out there as well.